It was film and television screenwriter Sidney Carroll who said, "A bargain ain't a bargain unless it's something you need." In this lesson, we're going to identify the difference between essential and discretionary expenses, determine the mean, median, and mode of a data set, use sigma notation to represent and determine the mean of a data set, create and interpret a frequency distribution table, and determine the mean, median, and mode of a data set presented in a frequency distribution table. All to answer the question, what do you need? What do you want? Let's make sure we're ready for this lesson by taking a look at warm-up number 2, which is which of the following expressions represents the statement 1/2 the sum of x and y? The answer is all three, A, B, and C, as 0.5 can be written as the fraction 1/2, and in C, the x plus y can be seen with invisible parentheses that could be there, and the divided by 2 would be the same as times 1/2. Now, let's take a look at a problem that you will be able to do by the end of this lesson. Transportation expenses to and from work are considered essential expenses. Charlie Jane would like to reduce the expense by biking to work rather than taking a car. She found 30 different ads, both online and in print, for the make and model of bicycle she wants to purchase. She made a list of all the prices in ascending order, which you can see here. She wants to analyze the prices, but is having trouble because there are so many numbers. How can she organize these prices into a helpful format? Charlie can set up a frequency distribution. A frequency distribution is a table that displays each value and its frequency, the number of times the value appears. This table to the right lists the price in the column and the number of times the price appears. So 250 appears twice. 275 appears 4 times, 280 only once, 290 appears twice, 310 appears 5 times, 315 appears 6 times, 320 appears once, 325 appears 3 times, 330 appears once, 335 appears once, 340 appears once, and 350 appears 3 times. She adds up the number in the frequency column to find the total frequency, which equals the number of prices of data in her data set. She wants to be sure that she did not accidentally leave out a price. Because there are 30 prices in the set, the sum of the frequencies is 30. Charlie Jane concludes her frequency distribution is correct. In this lesson, you will be asked to make lists indicating your spending, wants, and needs now and in the future. When making those lists, you probably consider your income. Right now, you may be on an allowance or have a part-time job. In 10 years, you could be a full-time worker in the military or continuing to pursue your education. As your life situation changes, your income, obligations, and expenses will change as well. Your income before all taxes are deducted is your gross income. Once the taxes are removed from that amount, what remains is known as disposable income. That is, you can dispose of the money, do with it as you see fit. Disposable income is used for 2 types of expenses: essential expenses and discretionary expenses. Now, let's identify the difference between essential and discretionary expenses. An essential expense is one that can't be eliminated from your day-to-day life. This might include rent or mortgage payments, utility bills, medical expenses, loan payments, and more. Although this type of spending is necessary, consumers usually look for ways to reduce the amounts. A discretionary expense is a cost for goods or services that are non-essential. This could include movie tickets, coffee, magazine subscriptions, and more. Wise consumers know how to balance discretionary and essential expenses to live within their means. Often, to do this, consumers use statistics. The branch of mathematics known as statistics involves the mathematical collection, organization, study, interpretation, analysis, and reporting of data. Facts that can be analyzed to obtain more information about a situation are defined as data. The use of statistics and data can help consumers make responsible decisions to maintain this balance. Data used to represent typical values in certain situations so that it is easier to make decisions are referred to as measures of central tendency. There are 3 measures of central tendency that you have learned in previous math courses that are used in this entire course. Mean is the typical value of a set of scores. It is determined by finding the sum of those scores and then dividing by the number of scores. It's an average. Median is the middle score. Mode is the most frequently occurring item or items. Both essential and discretionary expenses can vary greatly. Here you learn how to use some statistical measures to help you make sense of your expenses. Now let's determine mean, median, and mode of a data set. Alena knows that her morning cup of coffee is most definitely a discretionary expense. She pays $2.75 for a 9-ounce cup of coffee and was wondering if that is a typical price. On Monday, she asks 6 of her coworkers what they paid for a 9-ounce cup of coffee. Their costs per cup were $2.85, $2.15, $1.95, $3, $2.05, and $2.40. How can Lena compare her expense with those of her coworkers? Alena needs to find the mean of all 6 prices. To do this, we're going to add up all 6 prices and divide by 6. This is going to give us $2.40. Notice the fraction bar can be viewed as a grouping symbol that implies parentheses in the numerator around both the entire numerator and the entire denominator. The mean is $2.40. Alena's expense is 35 cents above the mean. Based solely on the data, she might want to look around for a less expensive coffee shop in order to save her some money on the discretionary expenses. Now, let's check your understanding and look at Nora is a college student. She needs to make an essential textbook purchase for one of her classes. She researches the cost of the book at her college bookstore and some local booksellers and some online merchants. The prices per book are $128, $118, $96, $102, $100, $118, $118, and $102. Find the mean of the textbook prices. If we add up all of these numbers, we're going to get 882. Now, there are 8 textbooks, so 882 divided by 8 is going to give $110.25. Often, mathematicians prefer to use compact notation rather than verbal definitions to indicate mathematical procedures. This is true for mean. We can use the expression x sub I to represent all of the numbers in the list. This is read as x sub I. The small number below and to the right of the x on the counter is called the subscript. So x sub I represents the first number in the list. So x sub 1 represents the first number in the list. Likewise, x sub 2 represents the second number in the list, and so on. There is a mathematical notation that indicates finding the sum. It is the Greek letter sigma and looks like this. The mean is often symbolized by an x with a line over it, which reads as x bar. The formula for the mean in compact symbolic form is x bar is equal to 1 over n sigma x equals 1 to n of x sub I. The variable I is called the index. I equals 1 beneath sigma indicates the starting number and n indicates the n number in the list, where n represents the total of the numbers or terms to be added. The formula can be read as follows. The mean is equal to the product of 1 over n and the sum of the numbers in the list. Finding the product of 1 over n and the sum is the same as dividing the sum by n. Now, let's use sigma notation to represent and determine the mean of a data set. Let's use the information about coffee prices from the first example. $2.85, $2.15, $1.95, $3, $2.05, and $2.40. To represent the formula for the mean price using compact notation. $2.85 would be X sub 1, and $2.15 X sub 2. $1.95 would be X sub 3. $3 would be X sub 4. $2.05 would be X sub 5, and $2.40 would be X sub 6. So X bar would be 1/6 times I equals 1 sigma 6 X sub I, which is equal to 1/6 times $2.85 plus $2.15 plus $1.95 plus 3 plus 205 plus $2.40, which is still $2.40. Let's check your understanding and see Andy's monthly water bill for the last year was $27, $31, $30, $26, $25, $27, $37, $33, $32, $28, $26, and $26. Express the formula for the mean using sigma notation and calculate the mean water bill for the year. This would mean that X bar is equal to 1/12 sigma from I equals 1 to 12 of X sub I. Now this is equal to 1/12 times the sum of all 12 of those numbers, which is 348, which gives us $29. Now, let's extend our understanding and Addie's monthly water bill for the last year being the same dollar values as the last. Suppose Andy only wanted the mean of the 2nd through the 7th month. Write the formula for this situation in sigma notation. This would mean that X bar would be equal to 1/6 sigma of I equals 2 through 7 of X sub I, which means 1/6 of the 2nd through the 6th values, excluding the ones that are not a part of that set. When added up, that is 176. Divided by that 6 gives $29.33. So what are the costs associated with items that you want but don't need? For that, we're going to take a look at Andy that wants to make a discretionary purchase of a basic laptop computer. He checks the price of a particular make and model listed by 7 different vendors on a shopping comparison website. He found the prices to be $850, $798, $2,400, $790, $836, $700, and $780. He computes the mean to be 1,022. This number doesn't seem to be a good representation of the data. How can he better represent it? In the prices, Andy found that there is an outlier, a piece of data that is extremely different from the rest of the data. When there are outliers, the mean is often not a good representation. In these cases, you can use the median to better represent the data. When the mean of the dataset is not equal to the median, this is a skewed dataset. The median is unaffected by the outlier. If the 2,400 price was 924,000, the median would remain the same. The median is a restraint to extreme numbers. There are 2 methods to use to find the median, depending on whether there are an even or odd count of numbers. An odd list is addressed here, and we'll do an even list in the next example, example number 4. When using either list to find the median, arrange the values in ascending order from least to greatest, or descending order from greatest to least. Pair the numbers starting from the ends of the list as shown here. In an odd count list, circle the middle number that remains after the numbers are paired. The median is the circled number. The number of scores below the median must be the same as the number of scores above the median. The median is $798. The price is a better representation of the data. Now, to check your understanding, let's construct a set of data for different discretionary expenses containing an odd number of scores with a median of 798. Identify the type of expenses you choose. Explain how the median is the same as the median from example 3, although the rest of the data is different. Now, answers can vary, but here are some airline fares from New York to Honolulu: $680, $700, $798, $850, and $920. $7.98 is the middle or the median of these 5 fares when arranged in numerical order. Now, suppose that Andy had found the first 6 laptop prices. When he conducted his online search, determine the median of those prices. As in example 3, we're going to arrange the numbers in ascending order, then pair the numbers. Since there are an even number of scores, there are no numbers left alone in the middle. Circle the 2 as a pair. To find the median, find the mean of those 2 numbers. So 798 plus 836 divided by 2, and that's going to give me 817. The median is $817. Again, notice that the number of scores below the median is the same as the number of scores above the median, and the median is resistant to extreme scores. Now let's check your understanding and construct a data set for a different discretionary expense containing an even number of scores with the same median of 817. Identify the type of expenses you choose. Explain how the median is the same as in example 4, although the rest of the data is different. Now, again, answers can vary, and this is just a sample. The cost of a particular computer tablet at 6 different stores are $700 and the $1,300 at the end, $750 and the $980 at the end. We're left with $800 and $832 or $834 in the middle. When we add these together and divide by 2, we get 817. A survey was conducted of 880 college students attending the same university. They were offered a list of 10 different internet service providers and asked to select the one they prefer. Can a service provider receive only 89 votes come out on top? This can be answered by determining the mode. The mode is often used with non-numerical variables, such as a preference survey. A set can have no mode. If there are 2 modes, the set is bimodal. If each of the 880 votes were split evenly among the 10 different internet service providers, each would get 88 votes, and there would be no mode. If one provider received 87 votes, another received 89 votes, and everyone else received 88 votes, the provider with 89 votes would win. Now, let's check your understanding and construct a data set for discretionary expenses other than the one from example 5, for which the mode is 56. Now, answers can vary, and this is just an example. Cab fares from Central City to the airport can be $35, $42, $48, $56, $60, $41, $56, or $66. You can see that 56 occurs twice, which would make it the most frequently occurring. In your mathematical studies, you have worked with bar graphs, histograms, circle graphs, and line graphs. You will now learn about a table that presents information about central tendencies in an easy-to-interpret format. You can use this table when examining data in order to make decisions about essential and discretionary expenses. Now, let's create a frequency distribution table. Charlie can set up a frequency distribution. A frequency distribution is a table that displays each value and its frequency, the number of times the value appears. This table to the right lists the price in the column and the number of times the price appears. So 250 appears twice. 275 appears 4 times. 280 only once. 290 appears twice. 310 appears 5 times, 315 appears 6 times, 320 appears once, 325 appears 3 times, 330 appears once, 335 appears once, 340 appears once, and 350 appears 3 times. She adds up the number in the frequency column to find the total frequency, which equals the number of prices of data in her data set. She wants to be sure that she did not accidentally leave out a price. Because there are 30 prices in the set, the sum of the frequencies is 30. Charlie Jane concludes her frequency distribution is correct. Let's check your understanding and use this frequency distribution to find the number of bikes selling for less than $320. Now, less than 320 means we are not including the 320 number. This means we're going to add up the 6, 5, 2, 1, 4, and 2 to get 20 bikes. Now, let's use a frequency distribution table to determine the mean of a data set. Find the mean of the bicycle prices, which are all on the table. Jane creates another column in the table for the product of the first two columns. The sum of the entries in the third column is 9,250. It is used to find the mean. This is the same sum you would find if you added up the 30 original prices. Divide that sum by 30 to find the mean, which is approximately 308.33. The mean of bicycle prices is $308.33. Now, let's check your understanding and say, what is the mode of the data set on the frequency table? Well, for that, we look for what is the largest number. The largest number in the frequency column is 6. That means $315 is the most frequently occurring price.